Hi, welcome to NPA teaching. Today I am going to discuss the adjoint of a matrix. A matrix in which every element of a given matrix is replaced with its cofactors, then it is known as cofactor matrix. Then take the transpose of a cofactor matrix, and this transpose of a cofactor matrix is called adjoint of a matrix. Thus, an adjoint of a matrix is the transpose of a matrix whose elements are the cofactors of a elements of the given matrix. Thus, for finding adjoint of a matrix, we have to be aware about how to compute minor and cofactors of a given matrix, which I have already explained in detail in the last video. The adjoint of a matrix is also known as an adjugate matrix. Adjoint of a matrix A is generally denoted by adjoint A. Consider the numerical example of a 2 into 2 order matrix. Matrix A is equal to 7, 9, 6, 12. And we want to find out the adjoint of a matrix. So for finding the adjoint of a matrix, we should be aware about how to compute minor and cofactors of a given matrix, which I have already explained in the last video. So here the minors are by crossing the rows and columns corresponding to the first element, which is equal to 12. In the same way, the second minor is equal to 6 and third minor is equal to 9 and fourth minor is equal to 7. And corresponding to the minors, we want to calculate the cofactors of a given matrix. In the same way, we also know how to calculate the cofactors where C11, that is first cofactor, which is equal to minus 1 raised to the power 1 plus 1, that is I plus j, that is first row and first column into the first minor, which is equal to minus 1 square into the first minor, which is equal to 12. So 1 into 12, which is 12. So first cofactor is equal to 12. In the similar level, we have the minus 6 is the second cofactor, minus 9 is the third cofactor, and the 7 is the last cofactor. So 12 minus 6 minus 9, 7 are the cofactors of a given matrix. After finding minors and cofactors, we want to find out the cofactor matrix. The cofactor matrix can be framed by replacing the each and every elements of a matrix A with its cofactors. Then it is known as cofactor matrix. So here the cofactor matrix is the C is equal to, instead of first element 7, here we are putting the first cofactor, that is 12, and instead of the second element 9, we are putting minus 6, and instead of third element 6, we replacing with the minus 9 the third cofactor, and instead of the fourth element of matrix here, we are replacing with the 7, which is the fourth cofactor of the given matrix. So we have a cofactor matrix. Matrix C is equal to 12 minus 6 minus 9 and 7. Now after finding cofactor matrix, we have to take the transpose of cofactor matrix. Transpose of a cofactor matrix means by interchanging the rows into columns and columns into rows, we will get the transpose of a cofactor matrix. So if you rewrite the given cofactor matrix with its transpose, then we have an adjoint of a matrix A, which is the transpose of cofactor matrix, that is C raised to the power t, which is equal to 12 minus 9 minus 6 and 7. If we have 3 into 3 order matrix, matrix A is equal to A11, A12, A13, A21, A22, A23, A31, A32, A33. Then for finding cofactor matrix, first we have to find the minor and cofactor. Then each element of matrix A is replaced with the cofactor. Then we will get a cofactor matrix like this. Then after getting the cofactor matrix, take the transpose of cofactor matrix, that is interchanging rows into columns and columns into rows. We will get adjoint of matrix A, which is C raised to the power t, that is transpose of cofactor matrix, which is equal to C11, C21, C31, C12, C22, C32, C13, C23, C33. So these are the elements of the adjoint A. So adjoint A can be found by taking the transpose of a cofactor matrix. Now consider the numerical example of 3 into 3 order matrix, and we want to find out the adjoint of given matrix A. So with the given matrix A, which we are already discussed in the last video, how to find the minor and cofactors. So from the given matrix A, the cofactors are minus 71, 54, 11, 39, minus 32, 15, 43, minus 14 and minus 10. So these are the various cofactors. So if you replace the each and every element of matrix A, that is 3, 6, 5 like that, we are replacing with the cofactors like minus 71, 54, 11, then we will get a cofactor matrix. So C is equal to cofactor matrix. After finding the cofactor matrix, we take the transpose, that is by interchanging rows into columns and columns into rows, we will get adjoint of A. So adjoint A is framed by interchanging rows into columns, that is the first row of cofactor matrix C will become the first column and the second row of cofactor matrix C will become the second column and the third row will become the third column. Thus, we have adjoint A matrix which is equal to minus 71, 39, 43, 54, minus 32, minus 14, 11, 15 and minus 1. Thus, once again I am repeating, for finding the adjoint of a matrix, first we have to calculate the minor and cofactors, then find the cofactor matrix, then take the transpose of a cofactor matrix, and this transpose of a cofactor matrix is generally known as adjoint A. I hope you are clear about how to find the adjoint of a matrix. If you are not subscribed to my channel, kindly subscribe to get the updated video by clicking subscribe button and the bell icon. Have a nice day and see you in the next video. Thank you.